but we're specifically going to look at definitions around solutions, calculations on dilutions, and then we'll briefly look at colour intensity. Our learning intentions are to evaluate colour intensity as a function of concentration, to consider calculation of the effect of dilution on concentration, and to explore primary standards and standard solutions. So, to begin, solutions. A solution is a completely perfect mixture of a solute and a solvent, and the mixture is usually homogeneous. The concentration of a solution is the amount of solute that is dissolved in a given volume of a solvent. In chemistry, we use standard solutions, and a standard solution is a solution of accurately known concentration, and that's a definition. It's prepared by dissolving a definite, precise mass of a solute in a suitable solvent to give a definite known volume of solution. And the preparation of a standard solution of sodium carbonate is discussed in another video. So standard solutions are used in titrations to determine the concentration of other solutions. Another definition to know is a primary standard, and a primary standard is used to make a standard solution. So a primary standard is a chemical which can be weighed out accurately to make up a standard solution. And primary standards have to meet certain criteria. These criteria include they have to be very pure, they cannot gain or lose mass when exposed to the air, they must be soluble in water, they should have a relatively high molecular mass, and that's to reduce weighing errors, so to reduce any chance of error when calculating the mass or the concentration, and they must react exactly as described by a chemical equation. There's only a small number of primary standards that exist and that satisfy the above criteria, and these include sodium carbonate, sodium chloride, and potassium dichromate. So the concentration of a solution can be often determined by its colour intensity. The intensity of a colour of a solution usually depends on the concentration, and the colour intensity can be measured using an instrument called a colorimeter, and we've met a colorimeter in our water chapter and water video. Usually, the darker the solution, the more concentrated it is. Often solutions can be diluted, and in titrations they often ask why a solution needs to be diluted. But when a solution is diluted, it means that more solvent is added, but that the quantity of the solute doesn't change. So if you take it as sugar and water, diluting a solution is adding more water to the solution that's already there. So since the volume of the solution increases, the same number of moles is present, so the concentration of the solution must decrease. And that's represented lovely by this visual here. As you can see, in a higher concentration, we have more of the red particles present in less of the white. And as you can see, in the higher, after we add the solvent and of a higher volume, we can see that there's a lot more of the white particles present and the red ones are more dispersed out. Dilutions often come up as a calculation as well, and basically it's important to know for a dilution that the number of moles of solute in a diluted solution is equal to the number of moles of solute in a concentrated solution. And that can be conveyed here using this formula, which says that the moles of a diluted substance multiplied by the volume of the diluted substance divided by 1,000 equals the volume of a concentrated substance by the molarity of a concentrated substance. So let's try an example. A student dissolves 17.5 centimeters cubed of acid to give 350 centimeters cubed of solution. Find the dilution factor. Now here you can use the formula. Now for this question you could use the formula, but there's no real need to use it. You can just use your kind of common sense. So if I put the 350 centimeters cubed and I divide that by the 17.5 centimeters cubed, that would tell me my dilution factor. It would tell me that I have a dilution factor of 20. So that means that the solution has been diluted by 20. So here's another example. It says, what volume of concentrated ammonia of 16 moles would be required to prepare 2 litres of 2 molar ammonia? So here you can see that this is a direct use of the formula. So as per usual, I will do out my little list of all of my values so that I know what I need to find. So the volume of the diluted solution is 2 litres. The molarity of the diluted solution is 2 moles. The molarity of the concentrated solution is 16 moles. And the volume is what we are trying to find. So if I go and fill that into the formula now, I get 2 by 2 divided by 1000 equals 16 by x divided by 1000. So if I multiply both sides by 1000, that gets rid of the 1000s. So that will give me 4 is equal to 16x. So x is equal to 4 divided by 16. So x is equal to 0.25. So I need 0.25 litres. 0.25 litres is 250 centimetres cubed. That's the volume that you would need of 16 molar ammonia to make 2 litres of 2 molar ammonia. Now, although it's rare for these type of questions to come up, it is important to know just in case. So that's it for this video. Make sure to read over the learning